Hello everyone, my name is Gautam Modala from Mechanical Second Year Regular, bearing pin number 24015A0304. Today I'm going to discuss on power factor improvement and battery backup solutions. So in this session we're going to discuss on topics of what is power factor, what are the different methods to improve the power factor, and what are the advantages we get on improving this power factor. And we're going to also discuss about what is battery backup solutions and also integration of power factor improvement and battery backup solutions. So firstly, we can understand what is power factor. Power factor is defined as the ratio of real power and apparent power in an AC circuit. So it indicates how effectively electrical power is being used. Lower power factor indicates inefficient power usage, leading to increased energy cost and potential equipment damage. So improving power factor is crucial for reducing energy waste, lowering utility bills, and enhancing the overall efficiency of electrical system. It also helps in minimizing voltage drops and improving the capacity of the existing electrical infrastructure. These are the advantages on improving the power factor. So the main advantages are reduced energy cost, improved system efficiency, increased system capacity. These are advantages we get on improving the power factor. Next, we're going to discuss what are the methods, different methods for power factor improvement or correction. The first method is by using capacitors. Capacitors are common and cost-effective methods for power factor correction. They work by supplying reactive power to counteract the inductive reactive power drained by inductive loads like motors or transformers, bringing the power factor closer to unity. So these capacitors supply the reactive power to compensate the power drawn by the loads like motors or transformers, so that the power factor can be close to unity. It means the power factor is maximum. So capacitor banks can be installed at various points in the electrical system, such as at individual loads or at the main distribution panel, depending on the specific needs and characteristics of the system. So proper sizing and placing of capacitors are essential for optimal performance. So by using the capacitors, the advantage we get are capacitors are low cost, simple installation, easy maintenance, and some of the demerits are fixed compensation, potential for resonance, harmonic amplification. And the next method for power factor improvement is by using active PFCs. Active power factor correction is an electronic technique used to control the amount of power drawn by a load in order to correct the power factor. Active PFC circuit use electronic components to shape the input correct waveform to match the voltage waveform, resulting in a power factor close to unity. So active PFCs offer several advantages over passive methods, including some of these advantages are high power factor correction, lower harmonic distortion, and improved voltage regulations. It is commonly used in power supplies for electronic devices and appliances. So the advantage we get by using these active PFCs are higher efficiency, reduced harmonic, improved regulation. So next, method for power factor correction. Another method is synchronous condensers. Synchronous condensers are rotating electrical machines used to provide dynamic reactive power compensation. These machines can supply or absorb reactive power as needed to maintain a desired power factor level, making them suitable for applicable with fluctuating load. So these synchronous condensers supplies or absorb power to maintain the constant reactive power on fluctuating loads. Whenever the power is needed, this supplies the reactive power, or whenever it is excess power, these absorb the power so that we can maintain the power factor as constant. Synchronous condensers offer several benefits, including continuous power factor correction, voltage support, and improved system stability. They are commonly used in large industrial facilities and power transmission networks to enhance power quality. So the advantage we get by using the synchronous condensers are continuous compensation, voltage support, and system stability. So we're gonna see a case study on power factor improvement in a commercial building. So they have studied a case on what are the advantages we get on power factor improvement. So this case study examines the implementation of power factor correction in a commercial building to reduce energy cost and improve system efficiency. The building's electrical system was analyzed to identify areas with low power factor, and capacitors banks were installed to provide reactive power compensation. So they have noticed that the area with low power factors, and they installed capacitor banks to provide the reactive power. The results showed a significant improvement in power factor, leading to reduced energy consumption, lower utility bills, and improved voltage stability. The payback period for the investment was relatively short, demonstrating the economic benefit of power factor improvement. So, by doing this, the result is the improve. The result in improvement of power factor is the energy consumption is reduced and the utility bills also reduced. So next, we're going to discuss about battery backup systems, types and applications. So battery backup systems are also known as uninterruptible power supplies, provides emergency power to critical loads during power outages. These systems typically consist of batteries, inverters, and control circuits to ensure a seamless transition to backup power. So these are mainly used to provide the power whenever there is a shortage in power. So to maintain the continuity of power flow, we use these battery backup systems. So these battery backup systems consist of batteries, inverters, etc. Uh, there are various types of battery backup systems, including standby UPS, line interactive UPS, and online UPS, each with different characteristics and applications. Battery backup systems are commonly used in data centers, hospitals, and other critical facilities to maintain continuous operating during power distributions. So mainly on data centers, hospitals, and industrial facilities. So, on integrating power factor correction with battery backup. So, integrating power factor correction with the battery backup systems can provide several benefits, including improved power quality, reduced energy cost, and enhanced system reliability. So, by correcting power factor, the load on the battery backup systems can be reduced, extending its runtime and lifespan. Additionally, integrating these techniques can help minimizing harmonic distortion and voltage fluctuation, ensuring a stable and clean power supply for sensitive equipment. Proper coordination and controls are essential for optimum performances. So by integrating power factor correction and with battery backup, we get different several advantages. So cost benefit analysis of power factor improvement. So by improving this power factor improvement, so by improving the power factor, what are the benefits, cost benefits we get? We'll see. A cost benefit analysis is essential for evaluating the economic viability of power factor improvement projects. This analysis should consider the initial investment cost, energy savings, reduced utility bills, and potential equipment lifespan. So the benefit of power factor improvement can be quantified in terms of reduced energy consumptions, lower peak demand charges, and avoid equipment maintenance costs. The playback period and return on investment can then be calculated to determine overall economic value of the project. So the reduction in energy consumption is 20% and 15% decrease in utility bills and 10% increase in equipment lifespan. So these are the benefits we get by improving the power factor. So as we're gonna conclude that power factor improvement and battery backup systems are crucial techniques for ensuring efficient and reliable power usage in various applications. Implementing these techniques can lead to significant energy savings, reducing costs, and enhance system reliability. So we conclude that by improving power factor, we get these many advantages. So recommendations are: it is recommended to conduct a thorough assessment of electrical system to identify areas with lower power factor and critical load requiring backup power. Based on the assessment, appropriate for power factor correction methods and backup systems can be selected and integrated for optimal performance. So by critically analyzing the uh, areas with lower power factor, and by using the suitable power factor improvement technique is very important for the optimal efficiency. So this is about the power factor improvement and battery backup systems, and hope you all understand. Thank you.